All right, let's get right into it. Today, we're talking about something absolutely essential, building the bridge between Python and SQL databases. You've got the awesome flexibility of Python on one side and the incredible data crunching power of SQL on the other. We're going to map out exactly how to make them talk to each other.
I mean, really think about it for a second. When you scroll your social media feed, or check your shopping cart, or see a game leaderboard, there's a lightning-fast conversation happening in the background. Your app is asking a database for some piece of information, and that database is firing the answer right back. What we're going to learn today is the secret language of that conversation.
So here's our game plan. First, we're going to touch on why this is so important. Then I'm going to give you a 6-step blueprint you can literally use for every single project. After that, we get our hands dirty. We'll look at how to read data, how to change it, and then we'll cover the most critical piece of the puzzle, how to handle user input safely.
At their core, you have to remember that a Python application and a SQL database are two completely separate things. Your app has all the logic, right? The brains of the operation. The database, on the other hand, just has the memory, all the raw facts and figures. To build anything truly useful, you've got to build a solid bridge between those two worlds. And the key to building that bridge is a little piece of software called a connector. The best way to think about it is like a universal translator. You see, Python speaks Python, and your database, let's say MySQL, speaks SQL. The connector is the genius in the middle that makes sure every command from Python is perfectly understood by the database, and all the data coming back is perfectly understood by Python. Now, the great news here is that connecting to a database isn't some kind of mysterious dark art. Nope. It's actually a super clear, logical set of steps. Once you get this blueprint down, you can use it over and over again for pretty much any project you can think of. And here it is, the whole shebang. Step 1, you import your translator. 2, you open up a phone line to the database using your login info. 3, you create something called a cursor, which is basically your messenger. 4, you hand that messenger your SQL command. 5, you either grab the results it brings back or you tell the database, yep, make those changes permanent. And finally, step 6, you hang up the phone and clean up the connection. That's it. 6 steps every single time.
Okay, so let's start with the most common task of all, playing detective. We just want to poke around the database, ask it some questions, and see what it knows. We're not changing a thing just yet. We're just looking.
So right after we've connected, the first thing we do is get that cursor. This little guy is our agent on the inside. We're going to give it our SQL command, and it's going to be responsible for running that command and bringing back whatever it finds.
Next up, we give our cursor its marching orders. We just package up our SQL command, like a classic select star from student, as a simple piece of text, a string. Python then hands this off to the cursor, which zips over and delivers the command right to the database engine. Once the database has run our query, the results are just sitting there, waiting for us. So we tell our cursor to fetch all of them. It scoops up all the rows of data, bundles them up into a nice clean Python list, and brings them right back into our app so we can actually use them. And here's a super handy little trick. After you fetch the data, you can check the cursor's row count attribute. It just gives you a number that tells you exactly how many rows your query found. In this case, our little detective mission turned up 15 records. Pretty neat, huh? Okay, playing detective was fun, but now it's time to put on our architect hat. We're not just looking anymore, we are going to actively change things in the database using commands like insert, update, or delete to make some real, lasting modifications. Now, this part should look really familiar. Just like when we were reading data, we define our SQL command as a string. This time, it's an update statement, and we pass it to our cursor's execute method. The actual process of sending the command is identical, whether you're just looking or you're making big changes. So, you've run the code. The cursor delivered the message. It feels like the job should be done, right? But hold on. Here's the critical question. Is that change actually saved? Is it permanent? If you went and looked at the database right this second, would those fees be updated? And the answer is a big, fat no. Not yet. This is so important. When you make a change, the database holds it in this kind of temporary waiting area. The changes only become real and permanent when you explicitly tell the connection to commit them. I'm telling you, forgetting this one line of code is probably the #1 mistake beginners make. And hey, look who's back, our trusty friend row count. After we commit the changes, we can check it again to get confirmation.
Here, it tells us that our update command successfully changed 4 different records. It's our proof that the job is well and truly done.
All right, let's pause for a second because we've arrived at the most important part of this entire discussion. Seriously, so far, all our SQL queries have been written by us, but real-world apps need to take input from users, and how you handle that input is the line between a secure, professional application and a disaster waiting to happen. This is your shield.
I want this to really sink in. This quote from the source material is not a suggestion, it's a command. SQL injection is one of the oldest, most devastating attacks out there. A clever attacker can type something into a form that tricks your database into running their commands, like say, delete all my data. The rule is simple and absolute. Never, ever, ever mix user input directly into your SQL strings. The whole philosophy of database security boils down to one word: separation. The dangerous way, on the left, is just mashing your SQL code and the user's data together into one big, messy string. The safe way, on the right, is all about keeping a clean wall between them. Your code stays pure code, and the user's input is always treated as simple, harmless data. And this slide right here shows you exactly what I mean. On the left, you've got the dangerous code. See that F string? That's just injecting a variable right into the command. Big no-no. But on the right, that's the safe, professional way. You use a placeholder, that little %s, inside your SQL, and then you pass the actual user data in as a completely separate variable. So how does this actually protect you? Well, it's pretty brilliant. The connector module sees that placeholder placeR and knows, okay, some data is coming. When you pass that data in a separate tuple, the connector acts like a security guard. It carefully sanitizes the data, stripping out any potentially dangerous characters before it ever lets it get close to the database engine. This is called a parameterized query, and it is your #1 defense. Whew, that was a lot. So let's recap the absolute essentials. First, always follow that 6-step blueprint for a solid connection. Second, use select and fetch all to read data. Third, always remember to use commit to save your changes. And finally, the big security rules. Never use F-strings or string formatting for user data, and always use parameterized queries with placeholders like %s.
And that's it. By understanding how to build this bridge between your application's logic and your data storage, you've really unlocked a whole new level of programming. You're not just building apps that run and then forget everything. You're building apps that have a memory, apps that can handle huge amounts of information and do truly powerful things.
So I'll leave you with this one question. Now that you have this fundamental skill in your toolkit, now that you can connect the world of code to the world of data, what's the first thing you're going to build? What problem are you going to solve?